everyone, welcome to week number 6. This week what we're really focusing with is going to be chapter 33, which is your dose calculation chapter. I know that online it says some different chapters, but I really want you to just focus on chapter 33. And what 33 talks about is really your responsibility as a medical assistant in the field. You may be responsible for administering medications. So when it comes to being able to administer them, you have to be able to read that physician order. And you have to be able to, if need be, do a dose calculation and make sure that you're being able to calculate the appropriate dose for a patient, along with reading the medication label and the warning labels. Now, when we talk about the medication order, you should be able to know what information is required on that order. So some of the things required on the order need to be the name of the drug that is to be administered, prescribed, or dispensed. It needs to have the drug form, whether it's an oral tablet, a sublingual, a topical, transdermal. You need to know what that form is going to be. You need to know the drug dosage. How much should that patient be given and when should they take it? Again, and that's part of the frequency, is how do they take it? Is it once a day, twice a day, 3 times a day, once a week, twice a week, something like that. And then the last one is going to be any special instructions, such as, do you take it with food? Do you take it on an empty stomach? Do you take it just before bed, or do you take it first thing when you wake up? Those are what we call special instructions. But it's also your responsibility as a medical assistant to be able to relay all this information to the patient and make sure that they understand it, along with any of the warning signs and warning labels that are on that medication. When we talk about a medication order, it can come from more than just that provider. It can also come from people such as nurse practitioners or physician assistants. Those are also considered doctors that can write prescription orders or medication orders for medical assistants and patients. Alright, so that's kind of a brief overview of the first part of chapter 33. I want to really get into the medication fundamentals and the math fundamentals. Now, don't panic when I say math fundamentals. It's really going to be very simple math. I'm not very good at math, so for me to be able to say that, it's going to be very easy. I promise you it will be very easy. But when we talk about math and then medication dosaging, there are really two types and two ways to be able to calculate a drug dose. One way is to perform a metric conversion. The second way is to set up an equation and solve for that equation and that formula. So we're kind of touch on both. But there are really two major systems that we use in the mathematics world and in the medicine world. One is called the apothecary. One is the metric system. Now, because we live here in the U.S., we are going to focus on the metric system. Apothecary is more going to be Middle Eastern or European. They use that kind of method, but we're just going to focus on the metric system, okay? So within the metric system, this is really a system that we refer to as a decimal system. And the reason that we do that is because each number goes up by 10, and it goes in multiples of 10, okay? Within the metric system, there are 14 prefixes, but because we live in the medical world, not all of those apply to us. The ones that we're going to be worried about are the micro, milli, centi, deci, deca, hecto, and kilo. Okay? Those are the ones that are going to be really important for you as a medical assistant to understand. And I want you to take a look at table 33.1. This gives a great breakdown of those systems and how those systems work and how to set up their conversions. Okay? So within our metric system, there are three main units that we use, and those units are grams, liters, and meters. Okay? Liters is going to deal with anything that's volume or liquid-based. Grams is going to deal with anything that is mass or weight, and meters is going to measure distance or length. Okay? There are 4 guidelines that you should be able to use and be able to follow in the metric system to help you with your dose calculations and dose conversions. First one being that all units except for liters are shown as lowercase letters, okay? What that means is when we say milligrams or mgs, that's lowercase m, lowercase g, liters gets to be a capital letter, okay? You want to leave a full space between the number and the unit, and that just makes it easier to read. There should be no commas in large numbers, so if you have a number that's 2,333, instead of doing 2,333, it would be just 2333, no commas. And you want to avoid mixing symbols and writing the unit out. It gets very confusing. If you're going to start with symbols, stay with symbols, okay? I want to start actually talking about metric conversions now. So when I say conversion, that means switching one unit to another. So for example, if I'm going to switch milligrams to grams, or vice versa, grams to milligrams, okay? Those are the ones you're going to deal with quite frequently in the medical world, milligrams and grams. So that's why I will reference them quite frequently. The conversion may be necessary when a physician's order is not available in the unit that they ask for. So if a doctor writes a prescription for 50 grams, but what you have on hand is milligrams, you need to do that conversion. It's not often, because doctors are pretty good about writing them in milligrams now, but if that was a situation, you would have to know how to convert grams to milligrams, okay? So the method used to convert is called a conversion factor method, and really that can be used for both performing conversions within the metric system or performing conversions between two different systems. I'm not going to talk a whole lot about that online. It's very hard to explain to you via the video, but we will spend a large chunk of our class time dealing with metric conversions and doing this in class. So don't panic. You're going to have plenty of time to practice it, okay? But I do want you to take a look, and it might even be a good idea for you to print a copy of Table 33.3. What this does is it actually gives you a common conversion unit and how you convert them. Now let's talk about calculating drug dosages for administration. So it's really important that you know how to do a drug conversion, because if it's not correct, you can end up doing great harm to your patient or even potentially killing them. So it's really important that this method is something that you learn, and that's why we're going to spend quite a bit of time working on it in class this week, okay? There are two methods that we use. One is called the rounding method, and one is called the proportional method. Proportional method is more frequently what we will use, and this is because it's really kind of complicated to describe in the video, but it's easier to practice in class, and it's going to be easier to understand than the rounding method, okay? But this is generally how you will calculate medication dosages for adults only, okay? The other two methods that we use are dealing with children. And because children are continuously growing, we need to take into factor their height and their weight when doing dose calculations. Adults is a little bit easier. They don't fluctuate as frequently as children do. So the two methods we use for children are called, they're based on BSA, or body surface area. And the formula is based on the average adult who has a BSA of 1.7 square meters. That changes for children, but in order to set it up, the important thing that you need to know is what the average adult BSA is. And again, that's 1.7. We will talk about this in class, and we will actually do some children BSAs, but I want to make sure that you guys actually do focus on reading that chapter and having a good understanding of what a child's BSA is and how to calculate that. The second method for children is by kilograms. So it's a little bit easier to use than the BSA method, but the first thing that you generally will do is you're going to convert the patient's weight in pounds into kilograms, and you do this by taking pounds and you divide it by 2.2. Okay? That's the ratio, 1 pound equals 2.2 kilograms. Okay? And then what you want to do is whatever your conversion comes out to be when you divide pounds by kilograms, you want to round to the nearest hundredth. That's the really important piece that you need to make sure that you do. The second step will be to multiply your new weight in kilograms by the patient's body weight. Okay? So you're going to take their height and calculate it, their weight and calculate it into kilograms, and then you're going to times it, the dose, by the kilograms of body weight. Okay? Then you're going to take the child's dose and dose number, and you're going to make it equal for how many doses they have to get in a 24-hour period, whether it's 3 times a day, twice a day, once a day. Okay? We will practice this one in class as well. I know it's a little confusing online, and it's a little confusing when you read it in your book, but we will have a lot of hands-on practice this week, so don't panic if you don't understand it just yet. Sometimes doing it hands-on is a little bit easier than listening to me talk and trying to read about it in a book. The last piece that I really want to talk to you guys about this week is how you read medication labels. So we've learned how to convert them, or you will be learning how to convert them in class with me this week. But medication labels are really important to know how to read because they give you a lot of vital information in regards to the medication, but also in regards to the warning labels. So you, as a medical assistant, really need to understand those and know how to read them. A product label or a medication label, more frequently just the product label itself, should have a tamper-resistant feature. Generally, that's at the top of the bottle. And just to show that nobody has put anything into it, it should be sealed. And the product name and dosage amount should be on the front, along with the active and inactive ingredients that can appear on the bottle, but sometimes it might be in that package insert that comes with the medication. The name and the address of the manufacturer, the packer, and the distributor. That's important because every manufacturer does things a little bit differently, and you might be allergic to how one manufacturer creates the medication. And then on the back of the label, it should list indications for use, dose instructions, warning labels, interaction problems, lot number, and expiration. You never want to take a medication that's expired, and reason being it's not good for your body, okay? So we know what a product label looks like, but let's talk about a prescription label. It's going to be a little bit different. A prescription label is going to actually have the product name, and that generally refers to the trade name or the brand name of the medication. It's also going to have the generic name, and that's the official name of the drug, and it can also be on the listing of active and inactive ingredients. You're going to want the NDC code, or that National Drug Code. The reason you want the NDC code is it proves that it's a real drug, and it actually goes back to the provider. And the dose strength, whether it's 10 units, 25 milligrams, 30 milligrams, that's the drug strength. Drug form, again, that's going to be oral, liquid, sublingual, topical, transdermal, all of those kind of things. The usual dose and frequency, the route of administration, the manufacturer's name, expiration date, lot control, and some other information such as the provider's name and phone number. Alright guys, that's kind of a brief overview of Chapter 33. I want to remind you guys, please make sure that you bring a calculator this week, or at least bring your cell phones that have a calculator, because I want you to be able to participate and be able to do the drug dose calculations, okay? You'll notice that in Angel, you have a lab activity Dropbox. Don't worry about doing anything in that Dropbox. There's nothing you have to do. We'll do everything in class this week, okay? You don't, like I said, you don't have to write a paper or anything like that. It's just strictly what we do in class, okay? This is the week I'm going to make up for week 4, where you had 2 assignments, because this week we're doing your homework in class. That's right, in class. All you have to do is show up and participate with me, and we will make it so you have no homework this weekend, except for doing, obviously, your discussion posts, okay, and your discussion post responses. So the other part for this week that I want to remind you guys of is your specialist referral project is going to be due that first 10 cards. Hopefully you've already been working on them and they are just ready to turn in. If not, those are going to be due Sunday at midnight. And your initial post is due Tuesday. Response is due on Saturday. And other than that, make sure you bring your calculators, and I will see you on Wednesday. Have a great week, ladies.